Hello, welcome back to our discussion about packages in Python, especially packages that are useful for mathematics. And the one we're going to talk about in this video is the scipy package. Scipy is not one that I'm going to use very often, especially as we're just getting to know Python, but it's got some really amazing tools that I think you're going to find handy. So the first thing that we want to really explore is which things are inside scipy. So I'm just going to go to scipy.org and take a look at what they've got. It is really designed to do scientific computing in a really efficient and fast way. So there are things like integration schemes, there's optimization, there's interpolation, there's a couple for signal analysis, there's linear algebra. And I know some of this, especially if you're like a first semester calculus student, many of these words are even going to be foreign to you. That's fine. There's one for statistics, there's image processing. In other words, lots of really good scientific packages are hiding inside of scipy. So let me just show you a couple of quick ones. For example, like in the integrate package, we can actually do integration very quickly. So if you've seen the idea of integration before, so I'm going to import scipy as sp, and then I'm going to do from scipy import integrate. Okay, so integrate is a sub-package inside of scipy. And let's just give it a function. I'm going to say I've got a function. It is the x squared function, because whatever, it's a nice simple quadratic. And say I just want the integral of that thing. From 0 to 1 of that function, f of x. All right, so what we would do is we would say integrate, because I've already included it. The quad command is hiding inside here, and it wants the function, the a, and the b. Okay, so I'm going to say f is my function. I'm going to go from 0 to 1, and I run it, and it says, okay, my integral is a third, and it even tells me that the error that it thinks it made in doing that computation is on the order of 10 to the minus 15, which is great. Okay, so that was a really quick, simple integration scheme. Here, let's do this. There, that way we know what the output actually is. Okay, there's an optimization routine here. So there's scipy.optimize. All right, so I'm going to say from scipy import optimize. And then I'm going to do optimize.fmin. Fmin is a minimization function. And I'm going to minimize this function f. Now, if you think about this, it's a quadratic that opens up. So the minimum should be at 0. I'm going to tell it to start looking near about like 0.1. And let's just see what it does. Okay, well, it still did my integral. That's kind of getting in the way. Let's hide the integral. There we go. Okay, optimization terminated successfully. The current function value is 0, so that would be where the y value is. And let's see here, and my optimal value is 0. So the x is 0 and the y is 0. Right, so if I did the function x minus 3, right, just moved it over 3 units, the x value is 3 and my optimum is 0. So scipy's got some nice tools that do that sort of thing. Now, if you're only in a calculus class, you can probably stop the video here. If you are in a class that does some linear algebra, I'm going to talk about the linear algebra packages inside of scipy because they are worth talking about really in depth. I'm just going to give you kind of the surface glance at them right now. So scipy.linalg is our guy, and he does all sorts of things linear algebra, like determinants, inverses, eigenvalues, solving systems, etc., etc. So I'm going to just demonstrate with a couple of matrices. I've got a matrix 1, 2, 3, 4, 5, 6, 7, 8, 10. And a vector 1, 2, negative 3. So I'm going to import scipy. Scipy is layered on top of numpy, so technically I could also have done, oops, not what I wanted. I should have also done import numpy as np. Okay, so I'm going to run this. I'm going to build 2 matrices here for A and B. That's just these 2 guys, and print them off. And now let's just do a few things. So scipy, I've given it the nickname sp.determinant, D-E-T. Oh, I'm sorry, scipy.linalg. I got to know which directory it's in. Determinant. So let's take the determinant of that matrix. And we did. And you can stop and check for yourself that the determinant of this matrix is -3. Well, let's take the inverse. scipy.linalg.inverse. I can take the inverse of that matrix, -2/3, -1 1/3, 1, so on and so forth. I can even say, let's see, I'm going to take A inv is that. Let's take A times A inv and verify that we actually get the identity matrix 1 0 0 0 1 0. Notice the scientific notation here 0 0 1. So it looks like I actually got the identity matrix. That's all good. Other things that we can do in the linalg package. Let's see here. I made a list up here. So we can do eigenvalues and eigenvectors. If you don't know what those are yet, it's coming. Right? So it'll give me my list of eigenvalues, and my vectors of eigenvectors is actually in a matrix. So the columns of that will be the eigenvectors. Notice that the eigenvalues are coming out to have some 0 complex pieces here. Not a big surprise if you've worked with these before. And then lastly, you can do a linear solve. This would solve the equation ax equals b, where x is a vector, of course, and it gives me that vector. So I'm going to call this thing x, and then I'm going to verify a times x, and it actually returns for me the b. So it does the linear solve for me in a very efficient way. Okay, so that's a really, really, really superficial, very quick look at what scipy.linalg has in it, and more generally, what the scipy library has in general. Scipy.org has lots of stuff that you should dig into if you're interested. Again, if you're maybe in a first or second semester calculus course, you're not going to hit the vast majority of what's in scipy. This will just come later. See you in the next video.